What do you think is the cost of emitting 1 tonne of CO2? And can we put a dollar sign next to people's lives, biodiversity, and sea level rise? In this video, we will look at what the social cost of carbon is, why it matters, and its significant limitations. So what is the social cost of carbon? It's essentially the monetary cost of emitting 1 extra tonne of CO2. In other words, if for example the social cost of carbon is 100, then emitting 1 extra tonne would cost the world $100. What do we use this number for, and why does it matter? Regulatory analyses and decision making in certain countries such as the US use the social cost of carbon. Many policies use cost-benefit analysis to see if a policy is essentially worth it or not. When it comes to the cost-benefit of implementing a climate policy, it's the difference between the cost of implementing the policy and the value of the damages caused by emissions that are prevented by that policy. But how do we get this side of the equation? Well, it's basically seeing how many emissions the policy prevents or reduces, multiplied by the economic value of emitting 1 tonne of CO2, in other words, the social cost of carbon. Another reason why we use it is that we struggle to visualize what saving tons of CO2 actually means. So putting a dollar sign can help successfully implement a policy. So how much is the social cost of carbon? In the US, it was first implemented under Obama, which was eventually set in 2013 at $50 per tonne emitted in 2020. Then under Trump in 2017, it was slashed down to around $7 per tonne in 2020. Biden put it back up to $51, and recently the Environmental Protection Agency suggested it should be $190 per tonne of CO2. So why did the numbers change? Well, first we need to understand how the social cost of carbon is calculated. The social cost of carbon is calculated using integrated assessment models, or IAMs, and there are 3 main models used with slight differences. These models generally follow a 4-step process. Firstly, you get an emissions pathway from projections of population growth and GDP. Secondly, the emissions pathway then drives a climate model that tells us how a change in CO2 concentrations affects temperature and other climate physical variables like rainfall. Thirdly, they place values on the monetary benefits and damages that these climate and temperature changes have on society. Fourthly and finally, they use a discount rate to discount future damages into present values. The discount rate used is very important when it comes to climate change projections. It seems the consensus is that it should be 2% or less, but the US had it at 3% for a while. The assumption with discounting the future compared to the present is that future generations will be richer and money is valued higher in the present than in the future. These assumptions tend to be justified by looking at the interest rates. However, these have been decreasing, which warrants some updating in what rates should be used. Some even argue it shouldn't even be positive and can be negative if living standards fall. So why were the actual social costs of carbons different? Well, there can be large differences in the social cost of carbon when different models are used with different assumptions, such as different damages and different discount rates. Under Trump, the discount rates used were 3 to 7%, and only domestic impacts were considered, which is why the social cost of carbon was so bloody low. The Environmental Protection Agency in the US recently put it up to $190 using a 2% discount rate instead of a 3% discount rate, and other small changes. Other countries also find different numbers, with Germany, for example, finding much higher values. What does academic research find? Many papers find results around the $150 to $250 mark, with this large study finding $185 per tonne of CO2 using a 2% discount rate. The discount rate matters a lot because here, for example, you can see that if they had used a 3% discount rate, then the mean social cost of carbon goes down to $80 per tonne of CO2. Or if it's 1.5%, it goes up to $308. I still need to explain what actually goes into the damages number. Different papers will have different damage functions and things that are considered. Common climate damages are changes in labour productivity, agriculture, sea level rise, mortality, and extreme events. In this paper, the $185 is composed of temperature mortality impacts, agricultural impacts, sea level rise damages, and increase in energy demand, mostly for cooling. A small side note, one of the reasons that this paper finds low sea level rise impacts is partly because it assumes that optimal adaptation to sea level rise is executed. This paper acknowledges its many limitations, especially when it comes to the damages, such as not including decreases in labour productivity, biodiversity loss, migration caused by climate change, and also not including potential tipping points, which I covered in another video. This recent paper here finds a mean social cost of carbon of $1,056 per tonne of CO2. How come? Well, to keep it simple, it looks at the effect of global mean temperature change on local impacts instead of solely looking at the impact of local temperature change on local impacts. They say that global temperature changes lead to bigger increases in extreme events at a local level than local temperature changes. They also find much higher carbon costs when lower discount rates are used. In general, the models used also have many other limitations, such as climate change affecting GDP, but not affecting the growth rate of GDP. Many other damages are also not included, such as ocean acidification. There is also the tricky question of how do you put a monetary value on deaths? Currently, lives are valued based on the income per capita of the country and on the value of statistical life, which is essentially how much people are willing to pay to reduce the risk of dying. This, in a way, implies that certain lives are worth more than others. So is an Aussie's life really worth 4 Indonesian lives? Well, no. Due to the uncertainty in damage functions and assumptions, other countries have gone for a different approach to put a monetary value on carbon dioxide, essentially choosing a temperature or emissions target first, and then working backwards from there and trying to find the most cost-effective way to get there. This is called the target consistent approach, which is often associated with Nicholas Stern and Joseph Stiglitz and uses marginal abatement curves to devise the most cost-effective route to a specific target, like 2 degrees. Some vouch for the social cost of carbon, others for the target consistent approach, but many don't see them necessarily as substitutes, and both give good insights. Many have criticized the results from models due to outdated assumptions, a lack of reflection of current science, and a misrepresentation of risks. It also doesn't take equity and inequalities into account, as certain people and countries are more impacted and have less means to pay for this impact. Also, impacts from climate change are non-linear, so the damage of emitting 1 extra tonne of CO2 depends on the overall emissions at that time. Overall, there are many criticisms that are valid and improvements need to be made, but some things that certain dummies say, such as, oh, it doesn't take into account positive benefits of climate change and we should use a 7% discount rate, are completely untrue and wrong. Only taking into account domestic costs like Trump did is also absurd, as A, emissions from other countries negatively affect the US and vice versa, and B, CO2 doesn't look at borders and say, oh damn, can't cross that. So global impact should be counted and discount rates should be low.
Why would you do that? Oh gosh, countless moral reasons.
So what do you think about the social cost of carbon? Thank you so much for watching. If you liked this video and want to learn more about climate change, don't forget to subscribe.